And here we go with another one of the investigations in our motion lab. Okay, this is station number 4. This one we're going to look at the forces that work on objects as they're moving down an inclined plane. As you can see, we have two Hot Wheels cars. These are two Mustangs that I happen to find at my local department store. The first thing here says, use the scale to measure the mass of the two Hot Wheels Mustang cars. Record the data in your notebook. Place one car at the top of each ramp and release. Which one will hit the bottom first? Try it again. Swap the cars. What happens? Why? What is the difference between the ramps? Give your response in complete sentences. Well, the green Mustang weighs in at 36.5 grams. The orange Mustang weighs in at 37.7. So a little over 1 gram difference in the mass. This is important because if gravity is acting on a mass, it may cause it to move faster. So here's the ramp right here. I have two different types of material. I have a smooth material here, as you can see shining in your screen. And I have this piece of styrofoam, which is quite, well, you can hear it right there, it's rather rough. So let's see, we place the two vehicles at the top of the ramp, and we let them go. The orange one hit the bottom first. Well, our investigation says to swap the cars around. Let's see if that actually is in fact what happens, because the orange car does weigh 1 more gram than the green car. We line them up as close as we can get to being even, and we let them go. Well, the green car hit the bottom first this time. What is it about this material? Now, we're looking for an F word here, because as you can hear, that makes a noise where here it doesn't. Here, we have little bumps and ridges in our material, so that might cause an issue. We're looking for an F word that came out of our chapter. The F word is friction. So could this friction that's acting on this vehicle cause it to not go quite as fast as the other one, even though they're relatively the same mass and the inclined plane is the same amount of slope? So therefore, it must be friction that's acting on the vehicle. And so that was station number 4. And as we come right around here, we look at station number 5. Station number 5 asks, let's see if I can get this in here for you to see a little better. Let's kind of zoom in on that a little bit. Station 5 says, investigation number 3, using the spring scale. Oh, that's where her thing went to. I have to save that. Okay, using the spring scale attached to the book, lift it and record the following: mass or pull in grams, mass and pull in newtons. Now, we have these nice spring scales where one side will give us a reading in newtons and the other side will give us a reading in grams. And the idea here is, let me back that out a little bit, to take this book, which I have strung up here, and suspending it in the air, record what is the amount of pull on this. In this case, it's approximately 1,700 grams, or approximately 17 newtons. So 1,700 grams is what this book is, the mass of this book suspended with only gravity acting on it, or about 17 newtons. Whereas over here, we have a book on an inclined plane. Same book, 8th grade science book, same spring scale, except here, what we want to do is we want to pull the book up the inclined plane and see exactly what does that do for us as far as the mass and the newtons. Well, in this case, it's coming in right at 5 newtons of force, maybe 6 to pull it, which is approximately 600 grams of force. So why is it so much different, the amount of force needed to move this object up an inclined plane, whereas when it was suspended in the air, it weighed approximately 3 times as much? I'll let you chew on that one for a little while. It says, use the spring scale attached to the book on the inclined plane. Gently pull it up the ramp. Record the amount of force needed in grams and newtons. Which required more force? Well, we think we have this one. Why? Same book, same mass. Please write your response in complete sentences. And that brings us to the next investigation. This one is number 4. Use the spring scale to lift the mass into the air. I'll show you this mass in just a moment. Record the mass in grams. Use the pulley to lift the same mass into the air. Record the mass in grams. Same mass, but was it easier to lift the mass using the pulley? Why or why not? Please explain your reasoning using complete sentences. So here's what we have here. Let me get my tripod back under me. We have this device here that has a pulley on the end of it. There's our pulley system. And here's our levers to actuate the pulley. And then we have the spring scale attached to a mass. And then we have just a mass with a spring scale. The spring scale, this is an older type. It measures grams on one side and ounces on the other. But let's see. Supposedly I have approximately 250 grams because the hanger weighs 50 grams. And sure enough, comes in right at 200, I don't know if you can see that, 250 grams. Now, if I have to sit here and hold this a while, I might get tired. Let's set that down. So I'm going to now use the pulley device. Let's see if I can get that in the picture for you here. There we go. Going to use the pulley device and I'm going to lift this up. Let's make sure I get that in there. Same mass. And I have to tell you, I barely feel it. And it is measuring in at approximately 250 grams. And with one finger, up and down we go. In this particular investigation, I'm not quite sure I had enough mass on there to make it worth it, because some students said it was easier to lift it than it was to just use the pulleys. However, theoretically, all of the students understood that the pulley should be easier than just lifting it up with your bare hands. And that brings us to station 7. In this one, we're going to investigate the lever. It says, use the lever to lift the book. Move the fulcrum in and out, and does the amount of force needed to move the book change? Why? Make sure and take notes as you move the fulcrum so you can explain your answers. Use complete sentences to explain your thinking. So here's what I have here. Let me move this back a little bit. Get you set as close to the table as possible and get you turned here where you can see. I'm going to back you out a little bit. There we go. I have this steel rod here is my fulcrum. I have this stick and I have a book. So the object is we stick the lever underneath the book. This is the arm of the lever. Here's the fulcrum right here. And let me just do this one finger. There we go. I can lift the book off of the table. But what happens if I move the lever down the fulcrum, still using one finger? Well, I have to push a little harder But if you'll notice, I get a little bit higher rise because I've extended the lever end over now is longer than the arm end. And if I roll the fulcrum all the way over here, and I'll leave just a little bit of arm length, it takes a lot of effort. I have to push quite hard to get this to go up, but as you can see, I can raise the book quite high. So, arm length long, amount of force needed small. Arm length small, amount of force needed more. And so that would be what we would get out of using the lever. And those are the 7 major stations. Now I have one more station with pulleys on it to illustrate how the pulleys work. So give me just 1 second and we'll come back with the third part of this video trilogy and look at pulleys.